Good morning, students. Let's continue the session with the quantum mechanical model of atom, which was developed by Heisenberg and Schrödinger. Actually, this is an old classical model which was based on Newton's laws of motion, successfully explained about the motion of microscopic objects like freely falling body or movement of planets around etc. But these classical laws which are based on Newton's laws of motion failed to explain the motion of microscopic objects like electrons. That is why there was a need of other theories which can explain satisfactorily about this motion of subatomic particles, right. At that moment, a dual nature of electron came into existence. Actually, this dual nature of electron or dual nature of matter was neglected or ignored by classical laws of physics. Right, but by considering this dual nature of matter, quantum mechanical model had given a more satisfactory explanation about the motion of subatomic particles like electrons. So, this was developed by Heisenberg and Schrödinger. Schrödinger developed a fundamental equation of quantum mechanics, which is h cap psi is equals to E psi. See, it looks very complex, no? Whereas where this h cap is called as Hamiltonian operator. What is h cap called as? Hamiltonian operator, which can be studied or understood with the knowledge of higher mathematics. You are going to study about this Hamiltonian operator in higher levels of mathematics in further higher classes, and this indicates the total energy of the system. The total energy takes into account of kinetic energy of all subatomic particles present in an atom, and all attractive forces between electrons and nuclei, and all repulsive forces between electrons as well as within the nucleus individually. And Schrödinger had developed an equation to describe the electron wave, which is given as a dou square psi by dou x square. What does this dou corresponds to? This DOE, dou means partial differentiation. DOE, dou stands for partial differentiation, and small d corresponds to complete differentiation. So, actually he considered partial differentiation, but in some publications they are using a symbol d directly. Let us study the actual presentation given by Schrödinger, which was dou square psi by dou x square, means this psi is a wave function. Psi is an electron wave function given as a function of 3 Cartesian coordinates x, y and z. Psi was given as an electron wave function in the form of f of x, y, z Cartesian coordinates. That function was differentiated, that electron wave function was differentiated with respect to x axis twice, y axis, z axis, and the summation is taken as a Schrödinger's wave equation. So, the equation can be studied as a dou square psi by dou x square plus a dou square psi by dou y square plus a dou square psi by dou z square plus 8 pi square m by h square into E minus V into psi equals to 0. So, this was the equation developed by Schrödinger to describe an electron wave function, and solutions obtained by solving this Schrödinger's wave equation, had given the possible energy levels around the nucleus, and wave functions of the electrons moving in those energy levels. Once again I am repeating, when this equation was solved for hydrogen atom, single electron species, they have noticed the possible energy levels around the nucleus, and also wave functions for the electrons moving in those energy levels associated with those energy levels were also determined, and these quantized energy states corresponding to wave functions, and corresponding wave functions are characterized. See, these quantized energy states and the wave functions of electrons moving in those energy states are characterized by a set of 3 quantum numbers, which are a consequence of Schrödinger's wave equation only. So, by set of 3 quantum numbers, namely principal quantum number, azimuthal quantum number and magnetic quantum number. See, electron was described as a wave. See, electron wave. For this, a wave function was determined f of x, y, z. And the amplitude of this wave also given with the symbol psi, and they tried to find the electron in a given region, for which they noticed that the value of psi was observed as positive above the axis, negative below the axis and 0 along the axis. So, negative probability means it is meaningless. That is why instead of taking psi, they considered psi square. They considered psi square by which is always positive. Psi square is always positive, and as psi square is always positive, thus we can conclude that electron can be identified or located at around the nucleus. Thus, as electron can be definitely located using psi square was defined as electron probability function. Psi square was defined as electron probability function or electron probability density. Psi is a wave function, psi square is a probability function. By plotting psi square around the nucleus, suppose psi square is plotted, this is the nucleus, psi square is plotted for a given electron at different times. So, thus they got the electron picture around the nucleus in a circular path, in a spherical manner, not circular, spherical, like this, in the form of a sphere. That region where the electron probability is maximum is said to be its orbital. Like this, by plotting psi square for an electron at different time intervals, electron probability and electron picture was clearly obtained, which was later named as orbitals. Means the region where the probability of finding electron is maximum was defined as orbital. Region where the probability of finding electron, where psi square value is maximum, was termed as atomic orbital. And these three quantum numbers clearly explains the quantized energy states and the corresponding wave functions, namely principal quantum number given with the symbol n, azimuthal quantum number given with the symbol L, and magnetic quantum number given with the symbol m. Thus, a large number of atomic orbitals are possible around the nucleus in an atom. A large number of numerous atomic orbitals are possible, and all these atomic orbitals can be distinguished, can be well distinguished with the knowledge of their size, shape and their orientation around the nucleus. See, in practice, around the nucleus an electron can move in different atomic orbitals. What is meant by atomic orbital? The region in which the probability of finding electron is maximum, means where psi square value is maximum. Okay. So, practically large number of atomic orbitals are possible around the nucleus, which can be distinguished from their size, shape and orientation. Like if the size is known, see, if the atomic orbital is smaller in size, means the probability of finding electron nearer to the nucleus is more. Smaller atomic orbitals means probability is more for finding electron nearer to the nucleus. Similarly, with the knowledge of their size and orientation, the probability of finding electron in certain region where orientation is known, where shape is known, will be more. See, with the knowledge of size and orientation of atomic orbital, probability of finding an electron in those regions will be more than other regions. Thus, an atomic orbital can be well precisely distinguished with the set of three quantum numbers, namely principal quantum number, azimuthal quantum number and spin quantum number. Principal quantum number, the first one is principal quantum number. So, who had given this principal quantum number? It was discovered by Niels Bohr. Already Niels Bohr had given this. It signifies, what is the significance of this principal quantum number? It signifies the main shell, or main energy level to which electron belongs. Shell means, shell is nothing but the all possible atomic orbitals at a distance, at a given distance, like with increase in n value, its energy associated with that shell also increases. With increase in n value, its energy associated also increases, size also increases. With increase in n value, size also increases, energy also increases. So, principal quantum number, this principal quantum number n, it is given with the symbol n, helps us in finding the radius of particular energy level and also in finding the calculation of energy associated for an electron in that particular shell or energy level. Actually, sum of all atomic orbitals under a main level or main energy level is termed as shell. A shell includes all the possible energy levels under a value n. A shell indicates all possible energy levels under a value n, means under this first shell so many sublevels are possible. Actually, the requirement of these shells, subshells, etc. had come from the splitting of spectral lines in electric and magnetic field, which we are going to discuss in the next quantum number, Azimuthal quantum number. See, using this, radius of electron can be calculated as 0.529 into n square by z angstroms for hydrogen like species. And energy of electron in nth orbit also can be calculated as minus 13.6 into z square by n square electron volt per atom. So, in this way, for hydrogen like species, radius of nth shell and energy associated with the nth energy level can be determined easily, right. With increase in n value, number of atomic orbitals associated with that n value also increases and are given with the symbol n square. So, n square indicates what? Number of atomic orbitals associated with the given n value, and these n value ranges for given as 1, 2, 3, 4 so on are designated as k, l, m and so on. N values are numbered as 1, 2, 3, 4 are designated as k, l, m, etc. K shell, L shell, M shell, N shell, etc. or first shell, second shell, third energy level, fourth energy level, in this way. And when it comes to this probability of finding also, when n value is smaller, electron is coming closer to the nucleus and hence we can find the electron easily. Probability is also more when n value is small. So, electron can be easily determined or position can be known at or nearer to the nucleus. When it comes to the Azimuthal quantum number, so this thought of Azimuthal quantum number was raised because of the splitting of spectral lines in electric and magnetic field. See, spectral line was observed as a combination of several small closely spaced lines, fine structure of atom. Similarly, splitting of these lines in electric field. So, what might be the reason for this? Sommerfeld had revealed a fact of a requirement of several sub-energy levels under every main energy level. See, splitting of spectral lines in electric field revealed the requirement of several sub-energy levels. In every main energy level. So, based on keeping this in view, Sommerfeld had given this Azimuthal quantum number discovered by Sommerfeld. It is given with the symbol L. Actually, the significance of this quantum number is it signifies the sub-energy level in which electron is present. It signifies the sub-energy level in which electron is present, and means the concept given with the Azimuthal quantum number is every energy level has several sub-energy levels. Sub-energy level concept was given by this quantum number, and this is also called as orbital angular momentum quantum number. Or subsidiary quantum number. This quantum number is also called as subsidiary quantum number or orbital angular momentum quantum number. And see, as it signifies the sub-energy levels under every main energy level, it signifies it signifies the sub energy levels under every main energy level. Under every main energy level means suppose n is equal to 1 first energy level, 2 second energy level, 3 third energy level. Under every this main energy level there are several sub energy levels about which Azimuthal quantum number describes. Means an electron is in first energy level. In that first energy level, in which sub energy level electron is present? That was explained by this Azimuthal quantum number. Suppose an electron is in third main energy level, third shell. In that third shell, when so many n square orbitals, atomic orbitals are possible, 3 square, 9 atomic orbitals. So, in which atomic orbital electron is present, in which sublevel it is present, sub energy level. So, in that way, this Azimuthal quantum number describes the shape of sub energy level or shape of atomic orbital, or sub energy level in which electron is present. Like these values, designations or values, designation is a better word than values, ranges, these values ranges from from 0 to n minus 1. 0 means it is not a null point here, 0 is a designation, For example, for first orbit, possible sub energy levels under this first sub level, under the first energy level, possible sub energy levels are 0 to 1 minus 1, 0 to n minus 1, 0 to 1 minus 1 means 0. There is only one sub level, under first main energy level, which was designated as S sub level. Similarly, under second main energy level, how many sub energy levels are possible? That was also described by this Azimuthal quantum number. So, under the second level, how many sub levels are possible? 0 to n minus 1. Here n is 2, no? 0 to 2 minus 1 means 1. So, this is again S sub level, and L is equals to 1 means that is P sub level, that was designated as P sub level. In this way, under every main energy level, the presence of several sub energy levels was described by Azimuthal quantum number, and under 1 there is only one sub level, under 2 there are 2 sub levels, under 3 there are 3 sub levels, 0 to 3 minus 1. So, S sub level, P sub level, D sub level. So, under every sub level there is an S sub level is coming, see. So, under 2 P sub level is there, under 3 also P sub level is there. Under fourth main energy level, how many sub energy levels are possible? 0 to 4 minus 1, 0, 1, 2, 3. So, this is S sub level, P sub level, D sub level and F sub level. In this way, the presence of sub levels under every main energy level was described by Azimuthal quantum numbers. And 0 indicates a designation. 0 indicates what? Designation. And totally, for a given nth energy level, how many sub energy levels are possible? See, for first level 1 sub level, second level 2 sub levels, third level 3, fourth level 4, under nth level, for a given nth level, n sub energy levels are possible. N sub energy levels are possible. When it comes to the next quantum number, that is magnetic quantum number, M, or given as ML, because it is with respect to the previous Azimuthal quantum number value. It indicates, it signifies the orientation of a particular sub-level. See, it was given by Landé. It signifies the spatial orientation of orbital with respect to standard set of coordinate axes. This magnetic quantum number was given by Landé, given with the symbol M subscript L, because it is for a given L value. It signifies the orientation for a given L value. Suppose this is n is equals to 1, 2, 3 main energy level. Under this every main energy level, there are several sub energy levels which was explained by Azimuthal quantum number. First main energy level has one sub level, second main energy has 2 sub levels, third main energy has 3 sub levels in this way. Third main energy has 3 sub levels in this way, like 0, 1, 2, so on. Third main energy level have 0, 1, 2, 3 sub-energy levels. This was explained by Azimuthal quantum number. Every sub-level has several orientation. Every sub-energy level has several orientations. That was explained by magnetic quantum number given by Landy. So, according to this, with a certain standard set of coordinate axis, every sub-level has possesses some orientations. Those orientations are given with these symbols minus L to plus L, minus L to plus L including 0, minus L to plus L including 0 means for L is equals to 0 sub-energy level, the orientations ranges from minus 0 to plus 0 means 0. Only one orientation is possible, that was designated as s orbital. Thus, s orbital can be described with the knowledge of principal quantum number, azimuthal quantum number and magnetic quantum numbers. Three quantum numbers helps us in describing an s orbital. Similarly, for under second orbit we have two sub-energy levels, under second main energy level we have two main sub-energy levels. This sub-energy level is S, this one is P sub-energy level. Now, for this P sub-energy level, how many orientations are possible? This is again same as the previous one. Under P sub-level, minus 1 to plus 1 including 0, minus 1 to plus 1 including 0. So, there are three orientations possible. Three orientations possible for a P sub-level. This is one orbital, this is another orbital, another orbital. Three P orbitals whose energy is same. Okay, these three are identical P orbitals with different orientations. Similarly, for azimuthal quantum number 2 under third orbit, let us take n is equal to 3 has 0, 1, 2, 3 sub-energy levels. These two cases we discussed in the previous mention. Now, L is equals to 2 means a D subshell it is. For a D subshell, how many orientations are possible? Minus 2 to plus 2 including 0 means minus 2, minus 1, 0, plus 1 and plus 2. Totally 5 orientations are possible. Each orientation indicates an orbital. Thus, every atomic orbital can be described with the knowledge of set of three quantum numbers like this. See, suppose if this atomic orbital is to be described, if this 0 particular atomic orbital is to be described, then we need a knowledge of its principal quantum number, azimuthal quantum number and the corresponding orientation quantum number, magnetic quantum number. And number of atomic orbitals also can be calculated for a given value of L, subshell notation and number of atomic orbitals possible and with this given L. So, for suppose L is equals to 0 means S subshell, 1 means P subshell, 2 means D, 3 means F, 4, 5, G, H, etc. So, S subshell, P subshell, D subshell, F subshell, etc. These are the corresponding azimuthal quantum number values for the given subshells. Now, every subshell, each of these subshell has several number of orientations. So, number of orientations possible for this is 2 into L plus 1. So, 2 into 0 plus 1, 1 orientation, 2 into 1, 2 plus 1, 3 orientations are possible, 3 atomic orbitals are possible. Each orientation can be considered as 1 atomic orbital. And for N is equals to 2 means D subshell, how many orientations, how many atomic orbitals are possible? 2 into 2, 4 plus 1, 5, 2 into 3, 6 plus 1, 7, 2 into 4, 8 plus 1, 9, 2 into 5, 10 plus 1, 11, 11 orientations means 11 atomic orbitals are possible under every subshell. Thus, these three quantum numbers, principal quantum number, azimuthal quantum number and magnetic quantum number well describes the atomic orbital in a given atom. But these quantum numbers, these three quantum numbers are not enough to explain the line spectra in a multi-electron species. Multi-electron species means more than one electron atom. Okay, because in a multi-electron line spectra of a multi-electron species contains sometimes the spectral lines as a duplet or a triplet or a quadruplet, etc. Duplet or triplet means 2 spectral lines are observed in every spectral line, 3 lines are observed in every spectral line in that way. Thus, this had shown the requirement of a new quantum number, new energy level other than the one we discussed, means other than principal, azimuthal and magnetic quantum numbers, there was a need of another quantum number that time, that was spin quantum number. The fourth quantum number later that was discovered was spin quantum number, given by Uhlenbeck and Gaudsmit. Spin quantum number was given by Uhlenbeck and Gaudsmit. It indicates the spin of electron around its own axis, like just like Earth revolves around its own axis, electron also revolve around its own axis according to this quantum number. There are then spin of electron around its own axis is possible in two ways. What are those two ways? Either in clockwise direction or in anti-clockwise direction. Electrons can spin around its own axis either in clockwise or in anti-clockwise direction. Clockwise spinning electron is conventionally given with the plus half, because this is given minus half, because when spin is an action and it has two probabilities, 50% probability is for clockwise and 50% is anti-clockwise. Anti, that sounds in a reverse way, that is why conventionally it is given as minus half. So, as a convention, for the first electron we give plus half and for the next electron we give minus half, that is it. Otherwise practically there is no such system, but as in a conventional manner we assign plus half for the first electron, minus half for the next electron, and the electron whose spin quantum number is given with plus half is given with an upsided arrow, whose spin quantum number is given with minus half is given with a downsided arrow. This is all a conventional system, right? And this indicates the spin states of an electron moving around the nucleus.